When you open a map or order food to your house, you might think your phone is communicating back and forth with satellites in space, sending signals to them. But that is completely wrong. Your phone does not send a single signal into space. In fact, the device in your pocket works more like a passive spy, secretly listening to hidden radio broadcasts coming from the sky. So, how can it determine your exact location on Earth, even the specific street you are on, just by listening? And even more astonishingly, if the clocks in space were not adjusted every single day according to theories developed by Albert Einstein over 100 years ago, today's navigation systems would guide you not to your favorite coffee shop, but to a completely different city. This is the story of the hidden synchronization of around 30 satellites in the sky and the unknown science behind navigation. The technology that makes our lives easier today was not originally created for civilian use. It was born out of the fear of nuclear war. It all began in 1957, when the Soviet Union launched Sputnik 1, the first artificial satellite sent into space. In the United States, a wave of panic spread across the country. At the time, two young American physicists working in a laboratory in Maryland began listening to the simple radio signals transmitted by Sputnik, purely out of curiosity. While monitoring these signals, they noticed something fascinating. As the satellite approached the laboratory, the signal's frequency increased, and as it moved away, the frequency decreased. Just like the siren of an ambulance rapidly passing by sounds higher at first, then becomes lower as it moves farther away. In physics, this phenomenon is called the Doppler effect. Then, the laboratory director, Frank McClure, walked into the room and asked the question that would change history. If we already know our own location, we can calculate exactly where the satellite is in space. But what if we reverse the process? If we treat the satellite's position as fixed, couldn't we determine where someone is on Earth? That was the exact moment the fundamental idea behind GPS was born. The project was immediately funded by the American military. Nuclear submarines hidden beneath the oceans had no reliable way to determine their position. If they were off by just a few hundred meters, the missiles they launched could miss their targets by kilometers. The first systems were built exclusively for those submarines. For many years, the system remained a military secret until 1983. A Korean Air passenger plane drifted off course because of a navigation error and accidentally entered Soviet airspace. Mistaken for a spy plane, it was shot down, killing 269 innocent people. After this tragedy, U.S. President Ronald Reagan announced that the military GPS system would eventually be made freely available to all humanity so that such disasters would never happen again. However, the military intentionally degraded the signal for civilian devices. Maps were always inaccurate by around 100 meters. Then, on the night of May 1, 2000, President Bill Clinton completely removed that restriction. Overnight, civilian GPS accuracy improved to within about 3 meters. The ride-sharing apps, digital maps, and delivery services we use today were essentially born that very night. So how does this system actually work? There is no need to drown in complicated formulas. The entire logic is based on measuring time. These satellites, constantly orbiting about 20,000 kilometers above your head, continuously whisper just one thing to Earth. I am satellite number 5, and I sent this message at exactly 12. Your phone receives that signal and checks its own clock. Let's say the signal reaches the phone when its clock reads 12.7. The phone then calculates distance equals speed multiplied by time. Since the signal travels at the speed of light, this tiny difference in time tells me how far away I am from that satellite. When we hear the signal from just one satellite, it means we are somewhere on a massive circle surrounding it, but we still cannot know our exact location. When we hear a second satellite, the possibilities shrink to 2 points. And when signals from the third and fourth satellites arrive, those invisible lines intersect at the precise spot where we are standing on Earth. Your phone is essentially a mathematician that finds its location simply by listening to the voices of satellites in the sky. Up to this point, everything works perfectly. However, there is a major problem. The speed of light is so immense that even a drift of just 1 millionth of a second in satellite clocks would mean your position being off by hundreds of meters. That is why the most precise clocks ever built, atomic clocks, are placed inside the satellites. But even then, something was still going wrong, because time does not pass the same everywhere in the universe. This is where Albert Einstein enters the scene. According to special relativity, time runs slower for objects moving at very high speeds. Since satellites travel at around 14,000 kilometers per hour, their onboard clocks tick about 7 microseconds slower per day compared to Earth. But that is not all. According to general relativity, time runs faster in regions where gravity is weaker. Since satellites are far above Earth and experience less gravitational pull, their clocks actually run about 45 microseconds faster per day. When you combine these two opposing effects, satellite clocks end up running about 38 microseconds faster per day compared to clocks on Earth. 38 microseconds may sound extremely small, but if engineers had not adjusted satellite clocks before launch according to these equations, in other words, if they had not programmed them to account for the 38 microsecond daily time difference in space, the result would be dramatic. The GPS system would drift by about 11 kilometers on its very first day and become completely unusable. Without the formulas written by Albert Einstein a century ago, today's navigation systems simply would not work. So, the next time you open a map on your phone and search for a cafe, remember the extraordinary system working in the background. Atomic clocks orbiting 20,000 kilometers above your head at 14,000 kilometers per hour, a legacy born from Cold War submarines, and the equations of a brilliant mind, all working in perfect harmony so you never lose your way.